Have you ever wondered how vast amounts of data, like the entire database of ChatGPT, are managed and queried? What if I told you that this immense sea of data is stored in something called a vector database? But what exactly is a vector database, and how does it manage to hold such colossal amounts of information? Why is it even required? Today, we're going to unravel the mystery of vector databases and explore their fascinating world, not through complex algorithms, but through a simple and beautiful analogy with a starry night sky. Let's dive in. A vector database is a specialized type of database designed to handle vectors. Now, vectors aren't just mathematical entities, they are n-dimensional points or arrays of numbers. In the context of AI and machine learning, data, whether it's a piece of text, an image, or a soundbite, is transformed into these vectors. These vectors are much more than just points. They capture the essential features, the semantics, and the very essence of the data. But why do we need to convert data into this format, and how does it help? Imagine trying to find a needle in a haystack. Now, scale that up to finding a specific piece of data in the vast universe of digital information. Traditional databases struggle with this, especially with unstructured data like images and text. Vector databases come into play here, offering a solution. They store these data points not just as isolated entries, but as interconnected vectors, making it incredibly efficient to search and retrieve complex data. Now, let's simplify this with our analogy. Picture a clear night sky, a canvas dotted with countless stars. Each star represents a piece of data. Alone, they're just points of light, but when connected, they form constellations, each telling a unique story. In our analogy, vector databases are like celestial cartographers. They chart the night sky, mapping out how each star or data point connects to form constellations or vectors. These constellations are patterns of related data, grouping similar images, texts, or sounds. The database maps and stores these constellations efficiently, allowing us to not just store data, but to understand and explore its interconnected nature. So, when we talk about vector databases, we're talking about a universe of data, intricately mapped and interconnected, much like the constellations in our night sky. It's this technology that powers systems like ChatGPT, enabling them to manage and retrieve vast amounts of information with astonishing speed and accuracy. In the world of data, vector databases are not just storage units, they are the map makers of the digital cosmos. Now that we understand what vector databases are and how they work, let's dive into how to actually use them, focusing on the critical step of converting data into vectors and the tools you can use for this process. The first step in utilizing a vector database is converting your data, whether it's text, images, or audio, into vectors. This means translating it into numerical values or points in a multi-dimensional space. Each dimension represents a feature of your data. For text, this might involve natural language processing techniques like tokenization, where words are broken down and represented as vectors based on their semantic meaning. In the case of images, convolutional neural networks, CNNs, can be used to process and translate the visual information into a vector format. For audio, techniques like mel-frequency cepstral coefficients, MFCs, help in converting sound waves into a usable vector form. There are several tools and libraries available for these tasks. For text, libraries like NLTK, Spacy, or TensorFlow can be used for vectorization. For image processing, OpenCV and TensorFlow are popular choices. For audio, libraries like LibRosa provide great functionality for converting audio into vectors. Once your data is in vector form, you need to choose the right vector database. Some popular vector databases include Elasticsearch, Face by Facebook AI, and Milvus. You store these vectors in your chosen database. This step is crucial as it involves not just storing, but also indexing the vectors for efficient retrieval. When you query a vector database, you use a vector as your query input. The database then searches for and retrieves the most similar vectors based on your query, using algorithms like cosine similarity or Euclidean distance. In conclusion, The journey from raw data to actionable insights through a vector database involves converting your data into vectors using appropriate tools and techniques, and then storing and querying these vectors in a suitable vector database. This process opens up a world of possibilities for data analysis and retrieval in the realm of AI and machine learning. Thank you for joining me in this technical dive into using vector databases. If you're interested in more deep dives into such technologies, don't forget to like, share, and subscribe. Until next time, happy data exploring.